today we're going to continue our work with with right triangles, looking at some special right triangles. In this second section of chapter 8, they talk about both a 45-45-90 triangle and a 30-60-90 triangle. Today we're going to talk about the 45-45-90, and then tomorrow we will talk about that 30-60-90 triangle. So our 45-45-90 triangle theorem says that in a 45-45-90 triangle, both legs are congruent and the length of the hypotenuse is square root of 2 times the length of the leg. So in your interactive notebook, you have a triangle diagram similar to the one you see up here on the screen. The only difference in your book is that they've used the variable x instead of the variable s. So again, we've got a 45-45-90 triangle, which means it's isosceles, because we talked about first semester, if two angles are congruent, their opposite sides are congruent. So that's what this theorem tells us, that both legs are congruent. They are equal to each other. And so we know those two sides are the same length. The hypotenuse is going to be square root of 2 times the leg, or I like to think about it the other way, because when we write things, when we write our numbers, the square root is always after a constant. So this is the theorem that or formula we will be working with today. The hypotenuse is equal to the leg times the square root of 2. So rather than using Pythagorean theorem, we are going to be able to use this formula, which will kind of shorten up the work that we need to do rather than using that Pythagorean theorem. Okay, so hypotenuse equals leg square root of 2. I would strongly encourage you to have that written on this page in your notes. Okay, hypotenuse equals leg times square root of 2. So we've got 4 examples that we're going to take a look at in your notebook. So this first example, I know because this is 90 and 45, this is also 45. So I do have that 45-45-90 triangle. I need to find both x and y. What do I know x is equal to? It is equal to 3 because my two legs are congruent. To find y, which is the hypotenuse, we're going to, again, use that formula. Hypotenuse equals leg times square root of 2. So my y equals, hypotenuse equals, the leg is 3 times square root of 2. Nope, that's it. Y equals 3 square root of 2. Okay? So that was much easier than doing 3 squared plus 3 squared equals y squared. So 9 plus 9, which is 18, equals y squared. Take the square root of both sides. Still got the same answer using Pythagorean theorem. That was a lot of work that I had to do. Okay? If it's a 45-45-90 triangle, we can use this theorem, hypotenuse equals leg times square root of 2, rather than plugging it into that Pythagorean theorem. So next example. Again, I've got that 45-45-90 triangle. My two legs are congruent, so I know y is 2 square root of 3. So my hypotenuse x, I'm going to write it down here, hypotenuse x equals the leg 2 square root of 3 times square root of 2. So what am I going to get when I multiply that together? Okay. If it's on the outside, so I just have the 2. Inside, I multiply them together. 3 times 2 is 6. Can I simplify the square root of 6? That cannot be simplified. So 2 square root of 6 is my answer for x. Again, I could have done Pythagorean theorem and got the same answer. But it would have taken me a lot more time and work to get there. This next example, again, we're using that formula. The hypotenuse is equal to leg times square root of 2. So here I'm looking for those two legs. I know they're the same because if these two sides are the same, the opposite angles are congruent, which means they both have to be 45. So I know x and y are the same, but that doesn't help me. I know the hypotenuse is 4. Okay? So I'm still going to use my formula. I just need to plug things in. So in place of hypotenuse, I'm putting 4 equals, in place of the leg, I can use either variable. I'll use x. And then I have times square root of 2. So I want to get that x all by itself. How am I going to get rid of that square root of 2? If I have something being multiplied with an x, how do I get rid of it? I divide by square root of 2. So the x is by itself. Okay? So I have 4 over square root of 2. I cannot stop there. Okay? When we learned about radicals in algebra, we learned that you cannot have a square root in the denominator. You cannot have square root in the denominator of a fraction. So we need to fix that. We need to get that square root out of there. Okay? And I know if I square it or take it times itself, okay, it's going to go away. So if I multiply by square root of 2, whatever I do to the denominator, I have to do to the numerator. So in the numerator, I have 4 square root of 2. In the denominator, what do I have? Just the number 2. Okay, that's the reason we took it times itself by that radical, because then it goes away. We get square root of 4, which is 2. So I have 4 square root of 2 over 2, but I need to simplify, just like when we multiply with division. If they're outside of the radical, we can simplify. So my answer, x, is 2 square root of 2.
Why can't you just square that square root on the bottom and then square the top too? Like if to get that out, though, can't you just square the 2 and then?
When we're working though with equivalent fractions, we have to multiply to keep it equivalent. Okay? If we squared it, okay, then we would get 16 over 2. Okay, that's not an equivalent fraction. So we always have to multiply something to make it equivalent. Okay, so we're multiplying by the square root of 2. So we get 2 square root of 2 for x, which means 2 square root of 2 is also the y. Okay, because x and y are the two legs. Okay. So occasionally you're going to have to go through this step. We call that rationalizing the denominator. Okay, we cannot have a square root in the denominator of our fraction. This next one, again, we're looking for the two legs. So using my formula, hypotenuse, 10 square root of 2 equals leg, so I'll use x times square root of 2. So just like we did with this previous problem, we want to get the x by itself. So I need to divide by square root of 2. When I look at that, this time though, I can go ahead and simplify. So I don't have to go through that rationalization process because I can divide out those square roots of 2. I simplify that fraction, and I'm just left with 10. So x is equal to 10, which means y is also equal to 10. So not on every problem will you see this step of rationalization. So it doesn't matter if you're looking for the hypotenuse, which we did in the first two problems, or we're looking for the legs, which we looked for in these last two problems. You're still using this formula, hypotenuse equals legs square root of 2. Plug in what you know, solve for the other.